All right, welcome. In this explainer, we're going to pull back the curtain on a topic that's absolutely fundamental for any GRC professional. What is actually inside the computers and servers you're responsible for protecting?
Now, you might be thinking, especially if your world is all about policy, audits, and controls, why should I care about the actual chips and circuits inside the box? And you know what? That's a totally fair question, but the answer is surprisingly simple.
It's because you just can't protect what you don't understand. To really manage risk effectively, to write policies that make sense, and to ask the right questions during an audit, you've got to have a grasp on the hardware where it all begins.
So here's how we're going to break this down. We'll start with a really helpful analogy. Then we'll look at the core components themselves, see how they all play together, and we'll wrap it all up with a GRC-specific checklist for you.
Okay, let's jump right in with a powerful analogy that's going to make all of this click. I want you to stop thinking of a computer as this complex, mysterious box and start thinking of it like an employee's office workspace.
Okay, this table right here, this is basically your Rosetta Stone for the next few minutes. The employee's brain, the part doing all the thinking, that's the CPU. The desk they're working on, their immediate workspace, that's the RAM. The big filing cabinet where everything gets stored away permanently, that's your hard drive. And the phone and mailbox they use to communicate with the outside world, well, that's the network card. Just keep this picture in your head.
Okay, so now that we've got that office analogy locked in, let's actually look at these components one by one. And more importantly, let's connect the dots to why each one really matters for your job in governance, risk, and compliance.
So first up, we've got the CPU, the Central Processing Unit. This thing is the brain of the whole operation. I mean, it's crunching billions of instructions every single second. Modern processors have multiple cores, which is just like having several employees working at once. It's how you can be on a video call and have a virus scan running at the exact same time.
Okay, so why does this matter to you? Here's the kicker for GRC. These processors, these brains, can have flaws, vulnerabilities, just like software can. And that means your patch management program has to cover hardware, firmware, not just your applications. A flaw at this level is a serious issue, and it absolutely belongs in your risk register.
All right, next up is RAM, or Random Access Memory. Think of this as the desk surface in our office analogy. It's where you put whatever you're working on right now. It's super fast, which is great, but it's also volatile. And what that means is the second the power goes off, everything on that desk is gone, wiped clean.
Now, this is where it gets really interesting for GRC. Super sensitive data. We're talking passwords, encryption keys, you name it, it all lives in RAM while it's actively being used. This means our data protection duties aren't just about files locked in the filing cabinet, it's about the live information sitting out on the desk. And that is exactly why physical security for devices is so incredibly critical. So if RAM is the temporary desk, storage is the permanent filing cabinet. This is the complete opposite of volatile. It's where your operating system, all your apps, and of course all your files and logs live, even when the computer's been turned off for weeks. Now when it comes to these filing cabinets, you're going to run into two main kinds out there. The older style, the traditional hard disk drives, or HDDs, which literally have spinning platters inside. And then there's the much faster, more reliable solid-state drives, or SSDs, which you'll find in pretty much all modern laptops today. And for you, as a GRC pro, storage is a massive, massive area of focus. I mean, think about it. A stolen laptop with an unencrypted drive? That's not just a lost device, it's an instant data breach. This is why auditors will always check for things like encryption, for secure data wiping processes for retired devices, and for clear policies that control how people use things like USB drives.
Okay, let's talk about the network card, the NIC. This is the computer's connection to the outside world. It's the telephone and the mailbox all rolled into one. It's the one piece that lets a machine connect to the internet or any other device. Without it, a computer is basically in total isolation.
And this is where we get a really great control point. See, every single network card has a unique serial number burned right into it. It's called a MAC address. Organizations use these for network access control. It's kind of like having a bouncer at the door of your network, checking an approved guest list to decide which specific devices are even allowed to connect.
All right, we've looked at all the individual pieces. Now for the fun part. Let's see how they all work together. We're going to trace one simple action, just double-clicking a file, and see what's actually happening under the hood. So, picture this. You double-click a file.
Instantly, the CPU, the brain, gets that instruction. It then tells the hard drive, the filing cabinet, to go find that specific file. The file then gets copied from the filing cabinet onto the RAM, the desk surface, where the brain can actually work on it. You make your edits right there on the desk, and when you finally hit save, the CPU tells the file to move from the desk back into the filing cabinet for safe, permanent storage. It's really just a beautiful, logical flow.
Okay, so we've gone through the office, we've seen how the parts work. What does this all boil down to for you, as a GRC professional? Let's pull together a quick checklist you can actually use in your day-to-day. First things first, and if you remember nothing else, remember this. You cannot protect what you have not inventoried. Effective GRC doesn't start with a fancy policy or a new control. It starts with a complete, accurate list of your hardware assets. If you don't know it exists, you can't protect it. Period.
So here it is, your GRC hardware checklist. 1. Make sure your patching program covers CPU firmware, not just software. 2. Remember that RAM holds live, sensitive data, which makes physical controls essential. 3. Mandate encryption and secure wiping for all storage. 4. Use those unique network card addresses as a powerful control point. And 5. Don't forget about the TPM, the Trusted Platform Module. It's a tiny security chip built into most modern computers that basically proves a device hasn't been tampered with, and your security standards really should reference it. And that leaves us with one final question to take back to your team. Now that you know about all these distinct components inside the box, from processors with their own firmware, to RAM holding live data, to those hidden little TPM chips, take another look at your asset inventory and really ask yourselves, is it truly complete?